All right, we're moving on to lecture number 3 of chapter 14, the digestive system. In this particular section, we're going to talk about the accessory digestive organs. So here we go. The accessory organs, which are teeth, the tongue, and several large digestive glands, assist the process of digestive breakdown in various ways, and we're going to discuss each one individually. Now, the role of the teeth play in food processing needs little introduction, right? We masticate or chew by opening and closing our jaws and moving them from side to side while continually using our tongue to move the food between our teeth. In the process, the teeth tear, and then they're going to grind the food and break it down into smaller fragments. Now, ordinarily by the age of 21, 2 sets of teeth have been formed. The first set is the deciduous teeth, also called baby teeth or milk teeth. The deciduous teeth begin to erupt around 6 months, and a baby has a full set, 20 of them, by the age of 2 years. Now, as the second set of teeth, the deeper permanent teeth, enlarge and develop, the roots of the milk teeth are reabsorbed, and between the ages of 6 and 12 years, they loosen and they fall out. That's when you get a little stuff underneath your pillow whenever the tooth fairy comes to see you. All of the permanent teeth, but the third molars, have erupted by the end of adolescence. Now, the third molars are also called the wisdom teeth. They emerge later, between the ages of 17 and 25. Although there are 32 permanent teeth in a full set, the wisdom teeth often fail to erupt. Sometimes they are completely absent, or you might have to have them taken out. We classify the teeth according to shape and function as incisors, canines, premolars, and molars. The chisel-shaped incisors are adapted for cutting. The fang-like canines are for tearing and piercing. The premolars and molars have broad crowns with rounded cusps and are best suited for grinding. Now here we can see the approximate time of tooth eruption is shown in the parentheses, and the same number and arrangement of teeth exist in both upper and lower jaws, so only the lower jaw is shown in each case. Now the shapes of individual teeth are shown on the right, as we can see. Now a tooth consists of 2 major regions, the crown and the root. The enamel-covered crown is the exposed part of the tooth above the gingiva, or the gum. Enamel, a ceramic-like substance as thick as a dime, directly bears the force of all of our chewing. It is the hardest substance in the body and is fairly brittle because it is heavily mineralized with calcium salts. Dentin, a bone-like material, underlies the enamel and forms the bulk of the tooth. It surrounds a central pulp cavity which contains a number of structures, connective tissues, some blood vessels, and some nerve fibers, collectively called the pulp. Now, pulp supplies nutrients to the tooth tissues and provides for tooth sensations. Where the pulp cavity extends into the root, it becomes the root canal, which provides a route for blood vessels and nerves and other pulp structures to enter the pulp cavity of the tooth. Wow, that was a mouthful. Now, the portion of the tooth embedded in the jawbone is the root. The root and crown are connected by the tooth region called the neck, and the outer surface of the root is covered by a substance called cement, or cementum, which attaches the tooth to the periodontal membrane, or the ligament. Everything you wanted to know about teeth, but we're afraid to ask. Here's a section of the tooth showing all of its parts. Now, we have 3 pairs of salivary glands emptying their secretions into the mouth. We've got a large parotid glands lie anterior to the ears. Now, mumps, a common childhood disease, and the inflammation of that parotid glands. The submandibular glands and the small sublingual glands empty their secretions into the floor of the mouth through tiny ducts. Now, here you can see the location of all those different kinds of salivary glands. The production of salivary glands, saliva, is a mixture of mucus and serous fluids. The mucus will moisten and help to bind the food together into a mass called a bolus, which makes chewing and swallowing easier. The clear serous portion contains an enzyme, salivary amylase, which is it's kind of like a bicarbonate-rich juice that begins the process of starch digestion in the mouth. Saliva also contains substances such as lysozyme antibodies that inhibit bacteria. Therefore, it has a protective function as well. And of course, last but not least, we've learned this before, that saliva dissolves food chemicals so that we can actually taste something, whether it's good or whether it's bad. Now, the pancreas is a soft pink triangular gland that extends across the abdomen from the spleen to the duodenum. Most of the pancreas lies posterior to the parietal peritoneum. Only the pancreas produces enzymes that break down all categories of digestive foods. The pancreatic enzymes are secreted into the duodenum in an alkaline fluid that neutralizes the acidic chyme coming in from the stomach. The pancreas also has an endocrine function. It produces the hormones insulin and glucagon. Now this figure shows the pancreas and how it empties into the small intestine. The liver is the largest gland in the body. Located on the diaphragm, more to the right side of the body, it overlies and almost completely covers the stomach. The liver has 4 lobes, don't forget that, and is suspended from the diaphragm and abdominal wall by a delicate mesentery cord. It's called the falciform ligament. There is no question that the liver is one of the most important organs in the body. It has many metabolic and regulatory roles. However, its digestive function is to produce bile. Right? Bile leaves the liver through the common hepatic duct and enters the duodenum through the bile duct. Okay, wow. Got all that? Now this shows you the location of the liver. See how large it is. It's got 4 lobes, don't forget that. Now, bile is a yellow to green watery solution containing bile salts, bile pigments, chiefly bilirubin, a breakdown product of hemoglobin. It has cholesterol, phospholipids, and a variety of electrolytes. Of these components, only the bile salts and phospholipids aid the digestive process. Bile does not contain enzymes, but its bile salts emulsify fats by physically breaking large fat globules into smaller ones, thus providing more surface area for the fat digesting enzymes to actually work on. Here we can talk about the gallbladder. This is the small, thin-walled green sac that snuggles in a shallow fossa in the interior surface of the liver. When food digestion is not occurring, bile backs up into the cystic duct and enters the gallbladder to be stored. Now, while in the gallbladder, bile is concentrated by the removal of water. Later, when fatty food enters the duodenum, a hormonal stimuli will prompt the gallbladder to contract and squirt out that stored bile, making it available to the duodenum. Now, here comes the problem. If bile is stored in the gallbladder for too long or too much water is removed, the cholesterol it contains may actually crystallize, forming something called gallstones. Now, because gallstones tend to be quite sharp, agonizing pain may occur when the gallbladder contracts. Now, we don't want that, because then you might have to go have it taken out. All right, what are the key points here? What is the normal number of permanent teeth? And let's think about it here for a second. Mary has a dry mouth, and very little saliva is being secreted. Digestion of what type of food would be affected or decreased by this situation? Got to remember what's in the mouth. What is the digestive role of bile? What organ secretes bile? And only one organ produces enzymes capable of digesting all the groups of food. Which organ is this? All right, that is the end of this lecture. Hope you enjoyed it. We're going to move on to the next one. Goodbye.